So there's kind of three main things that I think people outside of the scientific community, it's helpful to know. The first is that the evidence is overwhelming that this is caused by human activity, that the warming that's been observed is caused by human activity. And I'm just using a quote here from the Intergovernmental Panel on Climate Change's last major assessment report. And what's notable here is that they're saying the human influence on the climate system is an established fact. And I can tell you after 25 years of working as a scientist that that is not terminology scientists use lightly, right? Coming to call it an established fact means that the evidence is so overwhelming that we're willing to remove the usual contingency language that we use around likelihoods and percent chances and everything. And just to say, this is an established fact, like the things you learned in school in science classes are considered sort of established facts at this point, that gravity works, for example, right? That's the level of certainty. And that second point to remember is that scientists are certain about this. Now, how do we know this? This is a picture from an Intergovernmental Panel of Climate Change meeting. We know this because climate science isn't actually new science. Despite how it hears when you're out in the public, reading about these things in the media, climate science is just an application of physics and chemistry. And so it's grounded in the physics and chemistry that we've known for a very long time, or really been researching for a very long time. So this stuff is not actually new. We just have more data and we're applying it to what's happening to the planet, right? To give you an example that this is not new science, this is an article I often have students look at in my classes. This is from 1896. It's by the Swedish chemist Svante Arrhenius, and it was about on the influence of carbonic acid, which is another term you could use for carbon dioxide, in the air and the temperature of the ground. And so Arrhenius estimated how much the planet would warm if you doubled the amount of CO2 in the atmosphere, and he got an answer that's different than the answer we get today, but not that different than the answer we get today. And it's because there had been experiments done in labs in the 1800s that had shown that carbon dioxide and gases like it are greenhouse gases, and more of them in the air will cause warming on the ground, right? And the other thing to take home about this is that the reason we go from the fundamental science, like the fundamental theory, to being able to make those conclusions like an established fact is the meticulous nature of science, right? So scientists are like building engineers, right? They should go over everything with a fine-tooth comb, right? So things are replicated again and again until there's a strong enough certainty and enough evidence to say we know this beyond a reasonable doubt, right? And I'm going to give you the probably best example of this that's easy to explain. These are 6 different estimates of the global average temperature and how it's changed over time, going through until 2022. The 2023 data isn't obviously finished yet because the year isn't finished yet. So there's 6 different estimates because there's weather stations around the planet, and scientists might disagree about the best way to average all that data together. So they all use different methods, and replication, the key. The answers are similar. And I like pointing this out because of the green line. The Green Line, Berkeley Earth, is an organization that was started by a physicist at the University of California, Berkeley, who doesn't work in climate and thought, I don't trust what the climate scientists are doing. I don't like the way they do this weather data analysis. I'm going to hire a team of people. We're going to analyze the data a different way, and we are going to prove what's going on. And you may notice you can barely see the green line on the graph. It's actually almost identical to the other lines, right? So even somebody actually funded by organizations that were trying to disprove the science found the same result. Replication, again, part of the key. And so how do we come up with these statements? A lot of what is expressed through the public comes from the Intergovernmental Panel on Climate Change, or the IPCC. The IPCC is really a unique body that doesn't exist in other areas of science because the findings of climate scientists back in the 1980s, these early findings were having such a huge potential impact on governments around the world and decision-making. I mean, what it would mean for how we generate and use energy was so huge. The world's government said, well, we can't just have scientists talking about this willy-nilly. We need to have an organization where scientists are appointed by government to review everything that's out there, summarize and assess it for us, and then that's what we're going to take as the scientific canon. And so the IPCC was created. The Reagan administration pushed really hard for it. And it's not a fixed body. Every time the IPCC does a report, governments around the world appoint authors from their countries, and those authors then get together in groups and assess all of the research that's out there. So they're not doing any original work. They're just assessing everything that's known and then going through, and those reports are created. It's a multi-year process. It's extremely, extremely exhaustive, and I'm going to give you one example of this. I was on one of the lead authors of the last IPCC report. I was on a chapter related to oceans and coastal ecosystems, which is an area of my expertise. And this is a backing graph. You're not going to see this in the reports, but if you go online, you can download all this extra information. This is the supporting material for the likelihood statement in one sentence out of the 172-page chapter I was a part of, which was one of 18 chapters of a report that had 3 volumes, right? To point out that this is an incredibly thorough process. And if anything, the results that come from the IPCC, these summary statements, like climate change being an established fact, are conservative. Because if you bring everyone into a room and go through this incredibly exhaustive process and let the entire world scientific community review your findings before they're published, you're going to end up not talking about the extremes, but talking about where everybody agrees, right? And so the finding of all of this science, one of the key things is that climate change, as I mentioned, is going to continue until we reach zero or net zero emissions. We have to stop adding greenhouse gases to the atmosphere. And when the Paris Agreement was signed back in 2015, I think the thing that's most famous from the Paris Agreement was this call to avoid certain levels of warming, that we ideally want to avoid 1.5 degrees of warming, and if not, 2 degrees of warming. But if you read a little bit further along in the Paris Agreement is the really key statement that connects to net zero. So Article 4 of the Paris Agreement says this, that in order to achieve those temperature goals, we need a balance between emissions by sources and removals by sinks. So that's it. That's the world's government saying we need to get to zero, right? And we need to do so in the second half of the century. But there was no date on this, right? In the Paris Agreement, they also called on the Intergovernmental Panel on Climate Change, which is a separate body from the UN climate summits, but it's also coordinated by the United Nations, and said, we want a report where you tell us the difference between like what it would take to get to these different levels of warming. And so that report came out, and that report on global warming of 1.5 degrees is what inspired a lot of the protests you saw around the world. And those protests were driven by a sentence in the report. If we want to avoid 1.5 degrees of warming, we need to reduce emissions by almost half by 2030, by the year 2030, right? And so people saw the year 2030, it was 2018 at the time, said, oh, we have 12 years left. The report could have said we need 47% decline by 2031, and there would have been 13 years left. It was a bit arbitrary, right? But it's the end of that sentence that matters the most. To achieve this, we need to get to net zero around 2050. And so when this sentence was put in the report, this led to governments around the world, companies around the world, states and subnational actors around the world saying, we need a goal of net zero by 2050, right? Canadian government got in the act, passed Bill C-12, saying Canada now has a goal of net zero emissions by the year 2050. And as a part of that goal, we're going to need interim targets, and the government is going to need an advisory body that's hands-off from government to give advice on what are the pathways we can use to get there. And that's how the Net Zero Advisory Body that I'm a member of was created.